You are lying somewhere warm right now. Maybe under a blanket that has already learned the shape of you. Maybe with a pillow that has slowly, quietly, become the exact shape of your head. The room around you is dim, and if you listen closely, underneath everything else, you can hear the sound of your own breathing, slow and even, in and out, like a tide that never has to think about coming in. There is nowhere you need to be right now. Nothing you need to solve. No message to answer, no light to turn off, no thought that needs finishing. Your body already knows what to do next. It has done this every night of your life. All you have to do is let it happen, the way you always do, the way it always works. Tonight we are going to spend some time somewhere very small. Somewhere so close to the ground that most people walk right over it 100 times a day without ever noticing. We are going to spend the night, in our imagination, inside the quiet, tunneled, breathing world of an ant colony. And if you fall asleep before we get very far into it, that is not a failure of this story. That is the story working exactly as it was built to. Ants have been doing their patient, underground work for longer than there have been dreaming animals to watch them. They will still be doing it long after you have drifted off tonight, and they will still be doing it tomorrow, whether you are awake to notice or not. There is something very comforting in that. The world keeps its small appointments without needing you to supervise them. So let your eyes rest closed now, if they are not already. Let your jaws soften. Let your shoulders sink a little further into whatever is holding them up. We are going to walk gently, together, into a world underneath the world. You do not have to travel far to find them. They are, in fact, almost certainly closer to you tonight than you think. Beneath the floorboards of the room you are in, or beneath the pavement outside, or in the soil under a nearby tree, there is very likely a colony of ants going about its quiet business right now, in this exact moment, while you lie here listening to this. There are ants inside the walls of old houses, moving along paths so faint that a human eye would need to know exactly where to look to see them. There are ants beneath the roots of the grass in ordinary front yards, in numbers that would surprise almost anyone who has never dug carefully into the earth to look. Scientists who have tried to estimate the number of ants alive on Earth at any single moment have arrived at figures in the range of many quadrillions, which is a number so large that it stops being a number you can really picture and starts being more like an idea, a sense of vastness, a reminder that the world is fuller and busier than the eye can take in from where you stand. And yet, despite all of that vastness, an ant colony is also something small enough to hold an entire, complete civilization inside a space no bigger than a few shovelfuls of dirt. A world with workers and nurseries, food stores and highways, guards and messengers, all fitting neatly into darkness just beneath your feet. Tonight, we are going to shrink our attention down to that scale. Not our bodies. Just our attention. Just the part of you that is still curious even as the rest of you grows heavy and still. Long before anyone had microscopes, or scientific papers, or the patience for careful laboratory observation, people were already watching ants and wondering about them. Human beings have always been drawn to small, busy creatures who seem to know exactly what they're doing, especially when the humans themselves often do not. In the oldest layers of human writing that survive to us, ants already appear as teachers. In an ancient collection of wisdom sayings, a farmer is told to go and watch the ant, to consider her ways, and to become wise. The ant, in that old teaching, has no one standing over her giving her orders, and yet she gathers food in the warm months so that she will have something in the cold ones. To the people who first wrote that down, thousands of years ago, this must have seemed almost magical. How could a creature with no voice, no ruler, no one shouting instructions, still manage to organize itself so well? In ancient Greece, the storyteller we now call Aesop told a fable about a grasshopper who sang and played through the warm months while and quietly worked, gathering and storing. When winter came, the grasshopper had nothing, and the ant had enough. It is a simple story, almost stern in its simplicity, but underneath it is something gentler too, an old human respect for patience, for the kind of effort that does not need applause to keep going. The philosopher Aristotle, walking the hills and coastlines of Greece more than 2,000 years ago, noticed ants as well, in his careful, list-making way. He grouped them among the animals he considered political, meaning animals that live together in organized groups, alongside bees and, in his eyes, humans themselves. It is a striking thought that one of the earliest people to systematically study the natural world looked at a heap of tiny insects moving in and out of a hole in the ground and thought, here is something with a kind of society. In many cultures across the world, ants appear in old stories not as pests but as small teachers of virtue. In parts of India, some old traditions describe ants as creatures worthy of gentle treatment, feeding them small offerings of sugar or grain as a quiet act of compassion extended even to the smallest living things. In parts of the Americas, some indigenous traditions held stories in which ants were credited with bringing corn up from beneath the earth to share with human beings, a gift from underground given to those who live above it. None of these old thinkers had any way of knowing what we know now about ant biology. They could not see the chemical trails, the internal chambers, the underground nurseries. But they saw the pattern of it. Order without a visible orderer. Work without a whip. Cooperation without a spoken word. And they were moved to write it down, to turn it into wisdom literature, because on some level, they recognized something true, even without the tools to explain exactly how it worked. That patient noticing continued quietly for centuries, mostly through ordinary observation rather than formal study, until a slower, steadier kind of science began to take shape. In the 1700s, a French scientist named René-Antoine Furchot de Roma, already well known for his careful studies of insects, spent long hours watching ants build and repair their nests, recording what he saw with the unhurried attention of someone who genuinely loved the process of looking. He was one of the first Europeans to describe ant behavior with real scientific patience rather than simple folklore, treating the ants not as a metaphor for humans but as creatures worth understanding on their own terms. Later, in the 1800s, a Swiss scientist named Auguste Forel devoted much of his long working life to ants, eventually becoming known as one of the founders of what we now call myrmecology, the formal scientific study of ants. Forel was a careful, disciplined observer. He kept ant colonies in glass containers in his home, sometimes called formicariums, so he could watch their daily routines unfold in detail that field observation alone could never offer. He documented hundreds of species, describing how differently ants could behave depending on where and how they lived, and he helped turn what had been a folk fascination into a genuine branch of biology. Around the same period, the English naturalist Charles Darwin, already deep in his broader thinking about evolution, found himself puzzled and fascinated by certain ant behaviors that seemed, on the surface, to be at odds with his ideas about competition and self-interest. Why would a worker ant, who could never have offspring of her own, spend her entire life helping to raise the offspring of her queen instead? Darwin wrote about this puzzle honestly, admitting it troubled him, and treated it as what he called a special difficulty worth taking seriously rather than dismissing. It would take almost another century, and the mathematical tools of genetics, before scientists worked out a fuller explanation, something we will gently walk through a little later in the story. In the 20th century, two scientists working together, Bert Holdoebler and the American biologist Edward O. Wilson, spent decades studying ants with extraordinary depth, publishing what became one of the most detailed and celebrated books ever written on a single group of insects. Wilson, in particular, became known not just for his careful ant research but for a bigger idea he helped popularize, that a colony of ants might be usefully understood not simply as a group of separate individuals, but as something closer to a single living body, made up of many small parts working together, similar in principle to the way your own body is made of trillions of individual cells that never act alone, each one playing its part inside something much larger than itself. That idea, the superorganism, is one we will come back to gently later, because it may be the single most useful way of understanding everything else about how a colony spends its day. So let's slow down now, and actually walk through what a colony's day looks like, the way you might describe the daily rhythm of any small town. Picture, in your mind, a soft mound of earth, maybe hidden under a garden shrub, maybe tucked beneath a fallen log in a forest, maybe pressed quietly against the foundation of a house. On the surface, there might be very little to see. A small entrance hole. A scattering of tiny grains of displaced soil. Perhaps a few ants moving in and out, unhurried, following invisible lines only they can sense. But beneath that quiet surface, the colony is layered like a small underground city, with different chambers serving different purposes, connected by tunnels that the ants dug themselves, grain of soil by grain of soil, over months or even years. Near the top, close to the surface where warmth from the sun can reach, there are often chambers used for raising the youngest members of the colony, because warmth helps eggs and larvae develop more quickly. Deeper down, where the temperature stays cooler and steadier no matter what the weather is doing outside, there are chambers for storing food, and often, near the very center or bottom of the whole structure, a chamber reserved for the queen. Ants, unlike many animals we're used to thinking about, do not have a single boss barking out commands, and the queen is not a queen in the way a queen bee is sometimes imagined, and certainly not the way we imagine human royalty. She does not command her colony. Her main task, day after day, is far more physical than administrative. She lays eggs. In some species, she may lay hundreds in a single day, and depending on the species and her age, she may continue doing this for years, sometimes even a decade or more, which is remarkably long for an insect. The vast majority of the colony's inhabitants are her daughters, worker ants, all female, all sterile, all born from the same mother, sharing enough of the same genetic material that helping their sisters survive and reproduce actually serves their own biological interests almost as effectively as having offspring of their own would. This is part of the answer to the puzzle that troubled Darwin so long ago. Because of the particular way ants and their relatives pass on genetic material, sisters in a colony can be more closely related to each other than a mother is to her own offspring in some other animals. Helping raise more sisters, in a strange and beautiful evolutionary sense, is a kind of investment in one's own genetic future, even without ever becoming a mother yourself. A worker ant's day, if we can even call it that, since ants do not experience time in blocks the way we do, is organized instead around tasks, around signals, around the needs of the moment. Some workers spend their time as nurses, tending to the eggs and the small, pale larvae in the nursery chambers, moving them gently from place to place as temperature and humidity shift throughout the day, keeping them clean, feeding them carefully measured amounts of food gathered by others. Some workers become foragers, leaving the nest to search for food in the world outside, following the older trails of their sisters or striking out to explore unfamiliar ground. When a forager finds something valuable, a dead insect, a fallen seed, a drop of sweet liquid from a plant, she does something remarkable. On her way back to the nest, she lays down a thin chemical trail from a gland near the base of her body, a scent trail invisible to us but vividly clear to her sisters, saying, in the wordless language of chemistry, this way, this way, this way. Other ants crossing that trail slow down, sense the chemical signal, and follow it outward toward the food. If they find it, and if it is still there in worthwhile amounts, they lay down their own trail on the way back, reinforcing the path. This is how, without any single ant knowing the whole picture, without any map or meeting or spoken plan, a colony can settle, almost overnight, into using the single most efficient route to a rich food source, simply because more ants end up reinforcing the paths that work, and fewer ants end up reinforcing the paths that don't. The good trails grow stronger. The weaker ones fade, the same way a scent left too long in open air slowly disappears. There are guards, stationed near entrances, sensing the chemical signature of every ant that passes, distinguishing nestmates from strangers by smell so faint no human instrument could easily detect the difference, yet clear enough to an ant that trespasses unnoticed and challenged almost immediately. There are also, in many species, older workers who take on the more dangerous outdoor jobs, while younger workers stay inside doing gentler tasks like nursing and cleaning, a pattern some researchers call age-based division of labor. It is thought that this might be, in part, a quiet form of protection for the colony as a whole. Younger workers, with more remaining lifetime ahead of them, are kept safer inside, while older workers, who have less biological time left regardless, take on the riskier work outside. It is not a decision any single ant makes consciously. It is simply the pattern that has emerged, generation after generation, because colonies organized this way tended to survive a little better than those that weren't. Let's slow down again here, and rest for a moment on an image. Think of a river. A river does not have a brain. No single drop of water decides where the river will bend, or how fast it will flow past a certain rock, or when it will finally reach the sea. And yet a river behaves in remarkably consistent, almost intelligent-seeming ways, carving smooth paths over centuries, finding the easiest route downhill again and again, adjusting itself around obstacles without any planning meeting ever taking place. A colony of ants works a little like that. No single ant holds the blueprint for the whole nest. No single ant decides today we will expand the eastern tunnels, or today we will move the larvae to a warmer chamber. Instead, each ant follows fairly simple local rules, responding to smells, to touches, to the behavior of the ants immediately near her, and out of thousands of these tiny, local, uncoordinated decisions, something that looks remarkably like a coordinated plan emerges on its own. Scientists have a name for this kind of pattern: emergence. It describes what happens when many simple parts, each following simple rules, combine to create a larger behavior that looks far more complex and intentional than any individual part could produce alone. Your own brain, in a way, works on a similar principle. A single neuron cannot think. It can only receive small electrical and chemical signals and pass them along under certain conditions. And yet billions of neurons together, each one following its own simple local rules, somehow produce thought, memory, and the quiet awareness that is letting you understand these words right now. You do not have to hold on to that thought tightly. You can just let it rest there gently, like a small stone dropped into calm water, sending out slow ripples, and then let it settle. If you were small enough to walk the tunnels of a colony yourself, you would notice how carefully the architecture manages one of the hardest problems any underground creature faces: air. Deep tunnels can trap stale air, warm air, air heavy with carbon dioxide breathed out by thousands of small bodies clustered close together. Ants solve this, in many species, through the shape of the nest itself. Some colonies build mounds with a particular structure of chimneys and vents, allowing warm air from inside to rise and escape through the top, drawing cooler, fresher air in through lower openings, a kind of natural ventilation system built entirely from patiently moved grains of soil, with no engineer ever drawing up a plan. Researchers who have poured plaster or metal into abandoned ant nests, letting it harden and then carefully excavating the surrounding soil away, have uncovered castings that look almost like sculptures, intricate branching tunnels and chambers extending in some cases many feet beneath the surface, far larger and more complex than anything visible from above ground. Looking at one of these castings for the first time, it is easy to feel a kind of quiet, humbled awe. All of that, dug grain, by creatures smaller than a fingernail, working in the dark, without eyes capable of seeing very far at all, using touch, and smell, and something like an ancient shared memory carried in their instincts. Let your breathing settle a little deeper now. There is nothing urgent in any of this. You do not need to remember the details. You only need to let the pictures form gently in your mind and drift, the way clouds drift, changing shape without effort, without needing your permission. Ants have been walking the earth for an extraordinarily long time. The oldest ant fossils that scientists have found and confidently identified date back roughly 100 million years, preserved in amber, that golden, hardened tree resin that sometimes traps small creatures perfectly, keeping the finest details of their bodies visible for tens of millions of years afterward. Some of the ants preserved in this ancient amber look surprisingly similar to ants you might see in your own garden today, a reminder that whatever ants have been doing all this time, it has worked well enough that evolution has felt little need to change the basic design. Ants are thought to have evolved from wasp-like ancestors, gradually losing wings in most members of the colony, developing the particular body shape we recognize today, with its narrow, pinched waist and its highly organized social behavior. For most of the time since then, they have shared the world with dinosaurs, with early mammals, with the slow drifting apart of continents, and eventually with early humans, who inherited a world in which ants had already been quietly perfecting their way of living for tens of millions of years before the first human ancestor ever stood upright. There is something soothing in that time scale, if you let yourself sit with it gently. Ants were here through ice ages, through the rise and fall of countless other species, through slow shifts in climate and continents, continuing their patient underground work the entire time. Whatever difficulties any single day brings, the ants outside your window tonight are the descendants of an unbroken line stretching back further than almost any other animal group we know of. Their patience has already outlasted almost everything. Now let's bring the story back closer to you, back into your own daily life, because the truth is, ants are not distant creatures living in some far-off wilderness. They are almost certainly part of your everyday world, whether you have paid close attention to them or not. Perhaps you have noticed, on a warm afternoon, a thin line of ants moving along a kitchen counter or a windowsill, drawn by the faintest trace of something sweet or something oily left behind. Perhaps you have watched, as a child, a small group of ants working together to carry something many times their own size and weight, back toward a hidden entrance somewhere in the ground. Ants are, in proportion to their size, extraordinarily strong, with some species capable of lifting many times their own body weight, a feat that has fascinated scientists studying the strength and structure of small exoskeletons. Ants also play a much larger role in the health of soil and plants than most people realize. As they tunnel, they aerate the ground, allowing water and oxygen to reach deeper into the soil, which in turn helps plant roots grow more easily. In some ecosystems, ants disperse seeds, carrying them short distances and sometimes burying them, unintentionally helping certain plant species spread and germinate. Farmers and gardeners have known for a very long time, sometimes without fully understanding the science behind it, that a healthy population of ants often signals healthy, well-aerated soil underneath. Ants can also serve as a kind of quiet clean-up crew, carrying away small bits of dead insects, fallen crumbs, and organic debris, recycling that material back into the soil more quickly than it would break down on its own. In many ways, a functioning ant colony works a little like a small, tireless maintenance team for the patch of earth it calls home, doing work that mostly goes unnoticed and unthanked, the way so much important work in the world quietly does. In the modern era, scientists and engineers have started paying very close attention to that same pattern of small, simple, local decisions producing large, efficient, coordinated results, because it turns out to be useful for solving some very human, very modern problems. Researchers studying how ant colonies find the shortest paths to food sources through pheromone trails developed a branch of computer science sometimes called ant colony optimization, using simulated versions of these same simple rules to help solve complicated routing problems, like helping delivery trucks find more efficient paths through busy cities, or helping data move more smoothly through computer networks. In a strange and lovely bit of symmetry, the small, ancient behavior of ants leaving invisible scent trails in the dirt has helped human engineers design better systems for guiding traffic and information across entire countries. Robotics researchers have also studied ant behavior closely, building small robotic systems that mimic the simple, local decision-making of individual ants, hoping to create groups of inexpensive robots that could work together to explore difficult environments, like the rubble of a collapsed building after a disaster, without needing a single powerful central computer to direct every movement. Just as no single ant needs to understand the whole colony, these robot swarms are designed so that no single robot needs to understand the whole mission. The intelligence lives in the pattern, not in any one part. Biologists continue to study ant colonies as living laboratories for questions about cooperation, communication, and collective decision-making, sometimes drawing thoughtful, careful comparisons to how human institutions, cities, and even the human brain itself manage to coordinate enormous complexity out of countless small, individually limited parts. There is still so much scientists do not fully understand about ants, and that, too, is worth sitting with gently for a moment, because uncertainty is not the same thing as ignorance. It is simply the honest edge of what we currently know. Researchers are still studying exactly how ant colonies make certain collective decisions, like choosing a new nest site when the old one is damaged or destroyed. Some studies suggest that scout ants visit multiple potential sites, and through a quiet, almost voting-like process of recruitment and reinforcement, the colony gradually shifts its collective attention toward whichever site seems best, sometimes comparing several possible new homes with what looks, from the outside, like genuine deliberation, even though no individual ant is capable of comparing the options the way a human decision-maker would. Some researchers are studying how certain ant species appear to practice a very simple, primitive form of what could be called agriculture, cultivating fungus gardens deep underground, feeding the fungus with leaf fragments they harvest and carry back to the nest, and in turn feeding themselves and their larvae with the fungus that grows. This behavior, found in leafcutter ants of Central and South America, may have been developing for tens of millions of years, possibly making it one of the oldest examples of organized farming on Earth, far older than any human agricultural tradition. There is ongoing research into how ants communicate beyond simple scent trails, including through touch, sound vibrations too faint for human ears to easily detect, and a kind of tapping or stroking with their antennae that seems to convey information about food quality, colony needs, and even subtle emotional-like states, though scientists remain careful and precise about what language to use here, since it is not yet fully clear how much of what looks like decision-making in an ant genuinely resembles anything like feeling, and how much is closer to finely tuned, automatic instinct. It is one of the honest, open questions that keeps researchers patiently returning to their glass observation nests, year after year, the way Auguste Forel once did, more than a century ago. Let your attention loosen now, just slightly, the way a hand loosens naturally around something it no longer needs to hold tightly. You do not need to follow every detail from here. You can let some of the words simply pass by like distant, gentle sound, the way water passes over smooth stones in a stream. If we widen our view now, gently, the way a camera might slowly pull back from a single leaf to reveal the whole forest around it, we can start to notice how this small underground world connects to something much larger. The earth beneath your feet, wherever you happen to be lying right now, has been forming and reforming its surface for more than 4.5 billion years. Continents have drifted, oceans have opened and closed, mountain ranges have risen and slowly worn away into gentle hills. Ants, in the grand scale of their history, are almost impossibly new, having existed for only the last small fraction of that immense span of time, and yet within that fraction, they have spread to nearly every landmass on the planet except the very coldest regions, adapting to deserts, rainforests, mountains, and grasslands alike. Our entire planet, with its oceans and forests and quietly working ant colonies, orbits a star we call the Sun, one among roughly 100 billion stars in our galaxy alone, the Milky Way, itself just one galaxy among what is now estimated to be hundreds of billions of other galaxies scattered across the observable universe. The light from some of the most distant of these galaxies has been traveling toward us for billions of years, so that when astronomers look at them tonight through their telescopes, they are really looking backward in time, seeing those galaxies as they were long before Earth existed at all, let alone before any ant had ever dug a single tunnel. And yet, from within all of that unimaginable vastness, here is a small colony of ants, tucked beneath a patch of soil somewhere ordinary, quietly continuing its ancient, patient work tonight, the same work it was doing millions of years before there were any humans to notice it, and the same work it will likely still be doing long after tonight is forgotten. There is something both humbling and comforting in holding those two scales together in your mind at once. the almost incomprehensible vastness of stars and galaxies above you, and the quiet, dark, tunneled world just beneath you, both continuing on, indifferent to whether you are awake to think about them, both simply being what they are, moment after moment, the way your own breathing continues whether or not you are paying attention to it right now. You do not have to hold on to any of this. You can let it rest, like a photograph slowly fading at the edges, and let your mind soften around it. It is getting late now, and there is less and less that needs saying. Let your body settle a little further into wherever it is resting. Let your breathing continue on its own, slow and unhurried, the way it always does, without you needing to manage it. Somewhere, right now, beneath a patch of ordinary earth, a colony of ants continues its quiet work in complete darkness. Nurses tend to larvae they will never fully understand the future of. Foragers follow faint chemical trails laid down by sisters who came before them. The queen rests in the deepest chamber, her long, patient work of laying eggs continuing at its own steady pace. None of them are rushing. None of them are worried about finishing everything tonight. There is only the next small task, and the next, and the next, each one folding quietly into the one after it. Let the muscles around your eyes soften. Let your jaw rest, unclenched, heavy. Let your hands lie still, wherever they are resting, no longer needing to hold onto anything. Notice how your breath moves in without effort and moves out again just as easily, the way it always has, every single night of your life, whether you were paying attention to it or not. There is nothing left to do right now. The ants will keep tunneling gently through the dark soil, grain by grain, whether you are here to think about them or not. The stars above will keep burning their ancient light across the unimaginable distance of space, whether you are here to look at them or not. The world continues on, quietly, patiently, in your absence and in your presence alike, the way a river continues to flow past a sleeping town. Your breathing already knows how to carry you the rest of the way from here. The night keeps its own gentle watch, the way it always has, the way it always will. Let the weight of the day settle down into the mattress beneath you. Allow the last of your thoughts to grow soft and slow, and further apart from one another, like footsteps growing quieter as someone walks farther away down a long, dark hallway. There is nothing left to understand tonight. There is nowhere left to be. Only this soft dark. Only this slow breath. Only the quiet, patient tunnels beneath the earth, and the quiet, patient tunnels of sleep now opening gently underneath you. Rest now. Let it all